In this video, we'll be looking at how to incorporate error bars into plots and views. If you're using Excel, there's plenty of information online about how to add error bars into Excel plots. Here, we'll be looking simply at how to do it for views. As an example, we're going to return to the stock market data. And what we're going to do is we're going to do everybody's favorite thing, which is try to devise a means to beat the stock market. The crazy theory I have is that maybe as we go through each decade, year 0 through year 9, through the 1930s, 40s, 50s, 60s, 70s, 80s, 90s, and 2000s, a pattern will emerge. And so that one of these years throughout the decade will always give us a higher return than the other. Alright, so let's have a look. In order to figure that out, we're just going to average over all these years. To do so, I just need to type in something like the mean or average value return, and then say this is equal to the average of our values B2 through I2. That will average each year of the decade. Hit return. We'll copy this down. Now I know the average return for all of these cases. I'll save it and import it into views, and then we'll see what we get. All right. I'm now in views with the data imported. We're going to make a scatter plot. We already know how to do that. So I just need to select the scatter plot, select mean or years for the X, and then select mean for the Y, which maybe you can't quite see on this. So let me, well, you'll have to trust me. I guess I just selected the mean. And then look at this. I have years on the X and return on the Y. I can even add that in real quick if we want, just so we can keep track of it. So we'll say this is year, and then Y, return. All right. What do you know? If I invest in year 5 of every decade, I'm always going to get the best return possible. And bingo, we've beat the stock market. Of course, there's one problem, which is that if we look back at the data, then we might expect there's actually a range of returns, and that the mean that we've calculated is not the value we will always get. We'll have some fluctuation about that mean. And how to represent that? That would often be done by using error bars. So a standard thing to do is to enter standard deviation. Standard dev, and then we can use a formula for this as well. So standard deviation, we again want B2 through I2 is our values, and then we can propagate this down, and now we have the standard deviations associated with the mean. And a typical thing to do is to show symmetrically the plus and minus one standard deviation on a graph. So we want to import that into views in a way that will give rise to error bars. Views does not recognize stdev as a command. Instead, the way that it recognizes that you're going to add error bars to something is to head the column with plus minus. Plus minus tells views these are symmetric error bars associated with a column immediately to the left. In Excel, I find it's easier to type space first, because if you start with plus, it'll think you're trying to make a formula and it'll give you a hard time. So space, then plus, minus, enter. Now we're set up so that when we refresh this data within views, it'll know that the mean has errors plus and minus. So let's save this and go back to views and then see what happens when we refresh the data. We're back in views. We haven't refreshed the data yet, so we still have data without error bars. I can see, actually, by inspecting in the Data tab, what mean looks like right now. If I say Edit, I can see that I have data, and there's no entries to the right associated with symmetric errors, negative or positive errors, which will be what happens when we want to have asymmetric errors. And we'll end the video by showing you how to make that. So let me go ahead and close this. We'll refresh, which will read the file that now is coded such that views knows we have symmetric error bars. As soon as I do, you'll see the graph has changed, and now each one of these points has an error bar associated with it. If I go back to this data tab and inspect the mean values by saying edit data, I'll also see there's entries associated with the symmetric errors, and those are the numbers that were the calculated standard deviations. Great, so now we have these error bars. Maybe we want to change the way they look. That can be done under the formatting. There's two places that you can do this. The first is under main. So I'll go ahead and make sure I'm selecting the scatter plot under the editing tab. And then under the main in the formatting, I see there's at the bottom something called error style. Right now the error bars just end in a point. I can tell it instead I'd like it to end in bars. And now I have these flat lines at the end of the error bars. There are other options such as box, diamond, curve, and so on. These require that there are both errors in X and Y. Right now we just have errors in Y, so we'll keep it at bar ends. If I would like to further edit these error bars, then across the formatting tab pane, we go to the tab here that has the error bar line. Now I can change things like the color. Maybe I'd like them to be blue so they stand out from the red. Maybe I want them to be thicker so they're easy to see. I could make them transparent if I want to see what's behind them. I can choose to hide the error bars. I can also choose to hide just the horizontal, which we don't have right now, or just the vertical. One thing that's sort of nice about this is when I hide the vertical, it doesn't rescale the Y. And then lastly, I can change the end size. So if I change this to something like 10, you'll see the bar at the end gets quite long. It's sort of hard to see, so we'll keep it at something a little bit smaller. And what we find when we've added in these errors is that yes, even though the return does appear to peak right in the middle, there's still significant overlap in the errors between these years. You can decide if this is also enough to wager on always investing in the 5th year of the decade. Or I guess this would be the 6th year of the decade. But for me, maybe it's less convincing. All right, so this is how you add in symmetric errors. Let's think about how we want to add in asymmetric errors. To do that, let's go back and consider the data. One thing that you might like to consider is not only the mean value or its standard deviation, but how about the mean value and what the min and max returns were, but we want to indicate that with error bars. So what we'd like to do is have the mean value, we'll call this mean 2, because in views we can't have two columns with the same name, that will confuse it. And then I want to know the max value and the min value associated with that stretch of years. And so again, same formula, this is going to be the average from B2 to I2. To find the max, we just use the formula max. We're looking over the range B2 to I2. So all the years that were the 0 year of the decade, what's the maximum return? And then we can check using min what the minimum return is for those years, B2 to I2. Then we just propagate that down, and what we will have are the mean, which should be the same that we already had calculated, and then the max value for all these years, and the min value for all those years. And there's no reason to expect that the max and the min are symmetrically distributed, which is why we're listing them separately. Again, views does not recognize max and min as commands. It recognizes plus and minus. So instead of max, I'm going to put space plus. Instead of min, oh, there's an error there, space plus. Instead of min, I will use space minus. I can save this data and then go back to views to plot it. We're back in views. We will start a new graph, new axes, where we're going to plot our mean values with asymmetric error bars. I've already imported the data so that if we inspect the data pane down at the bottom right, here's mean 2. If I hit edit, we'll see that now there are the data, and also negative and positive errors associated with that data. Now, when I go ahead and plot the year versus mean 2, it will immediately come up with these error bars. You can see it defaulted to not having bar ends, so let's go back to the formatting under main and just say I'd like to have bar ends. I'm going to get rid of the lines connecting the points as well for this particular plot because I think it's a little bit easier to see. And what you can tell, hopefully immediately, is that we have some bars that have clearly asymmetric values, like this last one here. Okay, here's another one. And so this is how we can create error bars that are asymmetrically distributed, and now we have seen the range of values that one could expect in a decade with the mean value placed in that range using error bars. And now you know how to add both symmetric and asymmetric error bars as well as how to format them.